9.7, the quadratic formula. After this video, you might be a little stressed because, not stressed, but frustrating because sometimes in math, we investigate a lot of different things and then at the end, there's a really easy way to do things. And the quadratic formula is kind of the really easy way to do things for finding roots. We still teach factoring and completing the square and all those things because it makes for good problem solving, and I think it gives you a better appreciation of the different forms of quadratic equations. We've talked a lot about where the vertex is, what the roots mean, how equations relate to a graph, and I think those things really apply there. But there is such a thing called the quadratic formula, such that if you want to find the zeros, you can set your equation to 0 and get those. So if a quadratic equation is written in general form, in the form ax squared plus bx plus c equals 0, the roots are given by negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this formula will always give you the two roots, if there are any roots. Okay, we've seen in completing the square that sometimes you don't have roots. Sometimes parabolas look like this, or like this, or like this, or like this, where there are no roots. We never touch the x-axis. Okay, so if there are roots, this formula will give you them. This formula will also give you a glaring idea if there are no roots, and we'll see an example of that here. So make sure this is in your notes, and we'll move on to example A. Example A, we're asked to find the solution to the equation by using the quadratic formula. So I'm just going to go ahead and label, we have A, B, and C here. And for my own purposes, I'm going to write the quadratic formula. We have negative b plus or minus the square root of b squared minus 4ac all over the quantity 2a. So if I plug and chug here, that means I have a negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 7. Okay, all over the quantity 2 times 3, which equals negative 5 plus or minus square root of 25 plus 84. 4 times 3 times 7 is 84. Two negatives get us a positive, all over 6. Now, there's a couple different ways we can do this. We can say this is 5, 6 plus or minus the square root of, that would be 109 over 6. Okay, you can leave it as a square root, or you can figure out what your decimals are there. So if we have negative 5 plus the square root of 109 over 6, then that's going to give us 0.907. Or if we have negative 5 minus the square root of 109 all over 6, it's going to give us negative 2.57. So those are our two x values, and that's where our parabola is going to cross the x-axis. So at negative 2.5 and point something like that. Oops. Those are our two roots. Okay, moving on to example B. Example B, we have A of 2, B of negative 3, and a C of 2. So to plug and chug, we have a negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 2 all over 2 times 2, which reduces to negative third, or 3 is a positive 3, plus or minus 3 squared is 9, square root of 9 minus 16, all over 4. And then we realize that 3 plus or minus the square root of negative 7 over 4 is what we reduced to. Now, if you remember from prior units, this is not okay. We cannot take the square root of a negative number. There is no number when it is squared that it equals a negative number, because a negative times a negative will always equal a positive, and a positive times a positive will always equal a positive. We can never have a negative under the square root. So that is a huge key to knowing that there are no roots. If we graph this quadratic, we actually realize that it goes something like that. It never touches the x-axis. And that's why we don't have any roots. So, for class, I'd like you to try to solve the quadratic given here using the quadratic formula. And we will talk about it at the beginning of class. Remember to fill out the form and ask any questions that you might have so that we can talk about them at the beginning of class.